I've been thinking about something lately. If AI can already write a pretty good amount of code, what exactly are we supposed to get good at now? And I don't mean that in the dramatic, programmers are going to disappear kind of way. I mean it literally. If I'm learning programming today, what should I actually spend my time learning? Because a lot of the advice we've had for years was built around one assumption: you need to learn how to write software. Learn a language. Learn a framework. Learn databases. Learn APIs. Build projects. Get faster. Get better. And eventually, you become the person who can take an idea and turn it into working software. But AI is getting surprisingly good at that last part. You can describe something you want. It writes the code. It creates the files. It runs the tests. It finds an error. It tries a fix. Sometimes it can keep going until the whole thing works. And that makes me wonder, if writing the software becomes easier, what actually becomes valuable? At first, the obvious answer seems to be, okay, then learn architecture. And sure, architecture matters. But I don't think that's the whole answer either. Because AI can design architectures too. It can give you a React front-end, a back-end, a database, a queue, a cache, authentication, background workers, and make the whole thing sound extremely reasonable. The problem is that there can be 10 different architectures that technically work. And the difficult question isn't necessarily, can you design one? It's, why this one? Why this database? Why this abstraction? Why does this service exist? Why do we need caching here? Why is this asynchronous? What happens when it fails? What happens when there are 10 users? What happens when there are 10 million? And suddenly we're back to something that AI hasn't made disappear. Understanding. I think that's probably the first thing I'd still try to learn. Not because I expect to write every line myself, but because I need something in my head that I can compare the AI against. If an AI gives me 100 lines of code, I don't necessarily need to know every line by heart, but I should have some idea of what those lines are doing. Otherwise, I don't really have an AI assistant. I have a slot machine. I put a problem in, something comes out, and I hope it's right. And this is where I think debugging becomes really interesting. Because debugging was never really about typing the fix. The typing part was usually the easy part. The difficult part was figuring out what was actually happening. You expect A, you get B, so you start asking questions. Is the data wrong? Is the state wrong? Is the request failing? Is something happening in the wrong order? Is there some assumption I made that isn't true? You form a hypothesis. You test it. You eliminate possibilities. And eventually you find the actual problem. AI can help with almost every step of that. But it can also make the process weirdly harder. Because instead of one possible explanation, it can give you 10. And all 10 can sound convincing. So now the important skill isn't just, can I come up with a solution? It's, can I figure out which explanation is actually true? And I think that's a very different skill. The same thing happens with building products. You can tell an AI, build me a dashboard, and it will probably build you a dashboard. But what dashboard? For whom? What are they trying to accomplish? What information actually matters? What happens when there is no data? What happens when the data is wrong? What should the user be allowed to do? What shouldn't they be allowed to do? What happens when the network disappears? What does success even mean? Those aren't really coding questions. And yet they're exactly the questions that determine whether the software is useful. So maybe another thing programmers need to get better at is something that sounds almost too obvious, knowing what they're building. And this is where I think the role starts changing. Before, you could spend hours implementing a feature. Now you can spend 5 minutes describing it to an agent, and then spend the next hour figuring out whether what it built is actually what you meant. The implementation gets cheaper. The decisions don't necessarily get cheaper. If anything, they become more important. There's another problem here that I haven't really seen a satisfying answer to. How do beginners learn? Because normally, you learn programming by doing a lot of things badly. You write terrible code. You don't understand why it doesn't work. You search for the answer. You change something. You break something else. Eventually, you understand what happened. Then you see the same problem 6 months later, and you recognize it immediately. That's where intuition comes from. But what happens if AI removes a lot of those mistakes? What happens if a beginner never has to struggle with the boring part? They can build something much more impressive much earlier. That's great. But did they actually learn why it works? Or did they just learn how to ask for it? And I don't think the answer is to ban AI from learning. That doesn't make much sense either. If these tools are going to be part of software development, learning how to use them is obviously part of learning software development. But there's a difference between using AI to accelerate your learning and using AI instead of learning. And I think that difference is going to matter a lot. This is also why I'm not completely convinced that prompt engineering is the big new programming skill. Maybe it is useful, but if models keep getting better at understanding normal language, then memorizing the perfect way to phrase a prompt doesn't seem like a very stable advantage. The more interesting skill is knowing what you want to ask for, knowing what constraints matter, knowing what information the model is missing, knowing when its answer doesn't make sense, and knowing what to do next. In other words, the important part of the prompt might not be the prompt. It might be the thinking behind it. And honestly, this makes me look at programming fundamentals differently. I used to think of fundamentals as the things you learn before you can build real software. Syntax, data structures, algorithms, HTTP, databases, operating systems, concurrency, and then you move on to the real stuff. But maybe that's backwards. Maybe fundamentals become more important when AI can handle more implementation. Because the less code you personally write, the more important it becomes to understand what that code is doing. If an AI uses a database in a way you don't understand, you need enough knowledge to question it. If it introduces a race condition, you need enough knowledge to recognize what could be happening. If it creates an abstraction that makes the entire system harder to maintain, you need enough experience to notice. The code can be generated. The consequences can't. And then there's something even bigger. I think software development might slowly move from, how do I build this, toward, how should this be built? Those sound almost identical, but they're not. The first question is mostly about implementation. The second one is about judgment. And judgment is difficult to automate because it depends on context. There's rarely one objectively correct architecture. There's rarely one perfect product decision. There's rarely one debugging path. You have incomplete information, limited time, limited resources, a specific user, a specific business, a specific system, and you have to decide anyway. That's engineering. So if I were learning programming right now, I don't think I'd stop learning to code. That would actually be the opposite of what I'd do. I'd learn enough code that I can understand the machine I'm working with. I'd learn computer science because I want mental models, not because I want to memorize interview questions. I'd learn systems because small decisions eventually turn into large problems. I'd learn debugging because generated code can still be wrong. I'd learn testing because I don't want to rely on my intuition alone. I'd learn security because the AI said it was secure isn't a security strategy. I'd learn how products work because technically correct software can still be completely useless. And I'd learn how to work with AI, not as a replacement for those things, but as another tool inside them. But even after saying all of that, I'm still not sure there's a clean answer. And maybe that's the part that bothers me. We're watching the definition of programmer change while we're still trying to figure out what the new definition is. Maybe in a few years, manually writing most application code will feel as strange as writing assembly for a web app feels today. Maybe it won't. Maybe AI hits some limit. Maybe software gets so complicated that humans remain deeply involved for a very long time. I don't know. But I don't think the useful response is to pretend we already know exactly what happens next. What does seem pretty clear is that competing with AI at typing code probably isn't a very interesting strategy. If a machine can generate 1,000 lines in a minute, becoming someone who can generate 1,010 isn't going to save you. The more interesting question is, what can you understand that the machine doesn't? What can you notice? What can you question? What can you decide? What can you verify? What problems can you recognize before anyone writes a line of code? And maybe most importantly, what can you take responsibility for? Because eventually, someone still has to say, yes, this is what we're building. And yes, this actually works. And yes, I'm willing to ship it. Not away from code, but above it.